Hello everyone, welcome to IS 300. This week we talk about Enterprise Internet of Things. The keywords are Enterprise IoT, Consumer IoT, and Data Islands. There are several variants of IoT. The one that we have been talking about up to this point has been the consumer IoT, with smart devices and devices that are internet enabled, thermostats and cameras and all kinds of devices that can be used by consumers and connected to the internet. There's also an enterprise IoT, which sometimes is referred to as an industrial IoT. Those terms are interchangeable. That IoT, enterprise IoT, works for businesses, large businesses primarily, provides automation, advanced intelligence, and devices that are connected to the internet can generate data, which is very valuable for analytics purposes, for monitoring purposes, for automation purposes. It has revolutionized the industrial sector, and the implications for business are tremendous. The revenue that's being generated as a result of IoT devices is also extremely significant. Internet of Things. Three primary benefits in this week's discussion. Cost reduction. You don't have to pay as many employees. You can rely upon robotics. You can rely upon automation. And therefore, administration is improved and enhanced. It is less error prone, so quality improvement is easier, minimizes employing intelligent predictive maintenance. The costs are greatly reduced for maintenance. Regulatory compliance, making sure that the industry is meeting regulations, is also possible as a result of IoT. It provides the ability to collect data. As we talked about last week, edge devices are already collecting data. Why not use that data to make smart decisions? You can monitor your assets, your buildings, your equipment, the temperature, the conditions, the working conditions. All of those things can be monitored by collecting data. That data then can be sent to back-end applications for possible remote monitoring, control of the devices and assets. Data that's being gathered can be then sent to a back-end database for purposes of analytics. The analytics, very powerful, of course, and those analytics can be made available by the web and or mobile interfaces. Users can monitor remotely and get information in real time. Collected data then can be used for preventative maintenance, monitoring, predictions, estimations, things of that nature. This is the Enterprise IoT stack. It is a layered architecture, just as all of the other architectures that we've talked about in the discussions so far. At the bottom of the stack are the devices themselves, smart devices, actuators, and sensors that are using protocols that will allow for integration. The device itself then communicates with the intermediate layer. The business logic can then be implemented using middleware, standardization, and formatting the data so that it can be analyzed by moving it up the stack. So you've got analytics and artificial intelligence and machine learning capabilities that can be in play. And all of this data then can be sent to the top of the stack for purposes of running applications and services that are web enabled. What's the enterprise IoT solution? IoT can certainly have A positive impact on an enterprise, customer relationship management systems, supply chain management systems, enterprise resource planning, all of that can be done as a result of IoT. New business models are cropping up, quality of service is going up, and those critical assets can collect data. And so again, you get the advanced analytics, you get the artificial intelligence and machine learning, big data. All of those things are possible as a result of the data that's constantly being captured. Anyway, why not use that data for solutions and smart business decisions? The enterprise IoT has offerings of new products and services, enhanced visibility, of course, real-time visibility. Optimization can happen. New business models are cropping up again as a result of that. Quality is going up, and customer relationships and increased sales is a result of enterprise IoT. Of course, there are some factors that have to be made known. The differences between IoT and enterprise or industrial IoT. First, the security standards must be more rigorous for enterprise IoT because you're talking about a large enterprise. Imagine an Amazon, for example, or a Walmart, or a Microsoft software company, or something along those lines that does $1 billion in business as opposed to consumer IoT, which is for consumers, it makes it convenient and flexible. But in enterprise IoT, it is a whole different level of requirements because there's so many potential devices and revenue streams that can be affected as a result of a security breach. So threat detection, encryption, authentication technologies, devices that do nothing but monitor and surveil are part of the security in an enterprise IoT environment. Business processes have to be enhanced to support increased security. Fault tolerance. You have systems that must be up 24/7, 365. In some cases, they have to withstand extreme temperatures and extreme pressure. So the high availability is part of the equation. The failure rate, in some cases, you cannot stand any downtime, and therefore you have redundancy built into your systems, a redundancy which is not necessary in the consumer IoT, but is definitely required for an enterprise IoT. Interoperability, the ability to communicate with disparate systems and legacy systems that are in place. You can't afford to get rid of the legacy systems. You have to figure out how to operate with those systems. And there has to be a way to mitigate any conflicts in terms of integration. Application programming interfaces is the way that happens. Enterprise IoT has to be scalable as devices and or customers are added to an enterprise. You have to be able to accommodate those additions, and so enterprise IoT must be scalable. It must be accurate to a level of precision that is without a margin of error, which is not necessary in consumer IoT, but high precision and accuracy critical in an enterprise IoT system. Power requirements. You have to keep these devices running. Possible battery life has to be maximized, and therefore industrial grade batteries are used in enterprise IoT devices, and that those industrial batteries usually are powered through alternative energy sources such as solar. You can, of course, gain extremely valuable data by pulling information from industrial IoT devices, smart manufacturing for companies such as the Boeing company, which builds airplanes, and there is no margin for error when you're talking about an airplane. Smart healthcare devices that can monitor patients as well as provide administrative capabilities. Supply chain management, of course, for companies such as Walmart, Amazon, Target, big businesses that have billions of dollars in revenue streams and multiple vendors that they're dealing with all the time. Logistics becomes a very important part of it. Think about a company such as FedEx or UPS. Energy is also, we've seen it firsthand with the storm, that energy must be managed for purposes of the well-being of society. The components of an IoT, enterprise IoT, the devices at the bottom of the stack, the standards and the ecosystem, which requires a significant security, the platforms which must be deployed. Those platforms are a variety of platforms such as Windows operating systems, iOS, Android, Google, all of those operating systems, Linux, Unix, all of those platforms must be considered in the enterprise. Solutions and applications are also part of it. And then the monitoring and administration of those applications must be, it has to be managed. Challenges, of course, security, as we've talked about, the value of enterprise IoT devices in an enterprise landscape. How does it interact with legacy systems? How do you integrate these devices from a variety of platforms? How do you manage the volumes of data that is being pulled from these devices? How long will a project last? Because you've got, of course, the new devices that are coming on the horizon, implementing new technologies. So the length of the project, will have an impact. And standardization also is very important. The winning strategy, basically you need new skill sets. You need skills for enabling IoT manufacturing, firmware engineers, electrical and mechanical engineers, network, IoT, IT, and software engineers, manufacturing expertise. All of these skill sets are 21st century, 2021 and beyond skill sets that are being required because of the new technologies, the robotics, the machine learning, the artificial intelligence. All of those require a skilled workforce. That is one of the primary winning strategies of an enterprise IoT. You have to be able to balance technology and business, managing the volumes of data that are being generated on a daily basis, prototyping and looking at proof of concept, although you have to sustain daily operations at the same time. Integrating IoT with existing business flow requires new business processes and business process management strategies that have to be implemented. In conclusion, IoT and enterprise IoT or industrial IoT has tremendous potential to generate revenue. Challenges are also great. You need new skill sets. You need to implement IoT with a clear understanding of the challenges of security and management and administration. It is important to have a strategy that overcomes the challenges of enterprise or industrial IoT. Companies that have figured it out are the ones who are going to be successful and maintain a competitive edge. This has been discussion of Chapter 4, Introduction to Enterprise IoT.